Hi everyone, my name is Adam Muhammad Adam, a student in sensor technologies and application in the Department of Chemical Engineering and Biotechnology. My PhD research will focus on developing a smartphone add-on sensor using artificial intelligence for real-time fertilizer recommendation in African smallholder farms. African population is growing exponentially and is expected to reach more than 4 billion people by the year 2100. The productivity in Africa remains low for over 50 years, usually below 2 tons per hectare. In contrast with other developed nations like Europe and United States, where the productivity is very high, usually around 8 tons per hectare. This indicates that there's a huge gap in population and crop productivity in Africa. Therefore, African farming system must be transformed in order to feed the rapidly growing population. Agriculture in Africa is dominated by small-scale farmers, which constitute more than 80% of the farmers in the region. These farmers are constrained by so many factors, but poor soil fertility and blanket fertilizer recommendation, which fails to look at the variation in soil, variation in crop type, variation in management history, variation in cropping pattern, variation in cropping system, and variation in microclimate as a major constraint for crop productivity in the region. Therefore, the only way forward for African countries is adopting or adaptation of sustainable intensification strategies that will ensure soil health, increase productivity per unit input applied rather than per unit large area, reduce environmental impact, and minimize emission of greenhouse gases. All this can be achieved using innovative technologies. Technologies has been developed in the region quite all right, but most of these technologies have failed because smallholder farmers are highly heterogeneous. There's a clear differences in resource endowment that the will studies of the farmers. And most of this technology require large data set for calibration and validation, as in DSAT, AppSim, or even other models available. And they focus only on NPK fertilizer, despite the deficiency of other macro and micronutrients, which become very widespread, like sulfur, zinc, and boron. And this technology are mostly on station, and they require large amount of money or huge amount of money, and they are time consuming. Now, the best approach to handle heterogeneity or fertilizer recommendation in African farm system is going to soil-based test recommendation. This recommendation is very expensive for smallholder farmers in Africa because it costs between $15 to $20 to analyze 1 samples of soils. Now, what will be the way forward? Smartphones are now available in every part of Africa. It has been estimated that there are more than 700 million smartphones in Africa. Now, if we embrace the power of smartphone technology, will make a huge difference in the years to come in agricultural productivity. This research is designed to develop a smartphone add-on sensor that is economically viable, environmentally friendly, socially acceptable, and technically affordable in giving fertilizer recommendation very close or similar to soil test recommendation. Apart from that, the technology will be giving fertilizer recommendation a real-time measurement. And that is to say that it can capture within field and between field variability. And the technology will be focused toward 4R, nutrient stewardship. It will give the right type of fertilizer to apply, the right quantity, the right time, and the right method of application. And it will allow convenient farm monitoring, thereby enhancing crop productivity of the farmers. The objectives of the research are: number one, we'll design, fabricate, and develop the sensor that will be added on in the smartphone. Secondly, we will calibrate and optimize the sensor using hyperspectral matching techniques that employ the application of machine learning and artificial intelligence. Then we'll evaluate the performance of the sensor among different farming systems and agroecological zones in many parts of Africa. This is the roadmap for the development of the technology, which compose 4 fundamental stages. As I have said before, the first stage is design and fabrication as well as data collection. Archive soil data from diverse locations across Africa will be obtained from many research institutes. For example, in UK, we will obtain data from Rotherham State under a project called African Soil Information Service. Data set will also be obtained from International Soil Reference Institute, ISRIC, World Agroforestry Center, ICRAP in Nairobi, International Institute of Tropical Agriculture, IITA, and Center for Dryland Agriculture and African Center of Excellence. When all this data has been collected, we have designed and fabricated the sensor, we now move to stage 2, which composes the technology development. We'll do this stage through several processes, starting from sensor optimization, spectral decomposition, advanced chemometrics, and a lot of programming and artificial intelligence. The next stage is field validation. We are going to deploy the sensor in the real field testing. And this can be done in some farms across Nigeria, Ethiopia, and Kenya for model adjustment. And after everything has been done, real-time application will be started. The technology will be available for agricultural development agencies, for fertilizer companies, for government extension agents, and private extension agents. This will enhance crop productivity and soil sustainability under changing climate. Thank you for listening and for your time.